marathon supershoes. The individuals here are 18 elite male marathon runners. And we have a study examining for each one of them the energy cost of running on a treadmill at top marathon speed. But we are told that they either wear traditional marathon shoes, the Nike Streak, or the new Nike Vaporfly Super Shoe, which you may have heard of. Specifically, we are told that the participants run on a treadmill in random order with either of those shoes. So we know that for each individual, we're going to have one measurement when they were running with the Streak shoes and one measurement when they were wearing the Vaporfly shoes. The participants didn't choose which shoe they were going to use. Random order was used. That means that we have an experiment with repeated measures, match pair design, or crossover design. So the objective of the study is to compare the energy cost of running with those two types of shoes for elite marathon runners. That means that what we are fundamentally truly interested in is this already computed pairwise difference in energy cost with the Streak minus with the Vaporfly. So when we want to estimate a parameter of interest here, that would be the mean of this variable in a population of individuals like the one studied. That is, we're going to be interested in the mean difference mu diff S minus V for the population of all elite male marathon runners in treadmill conditions running at top marathon speeds. Now we want to obtain a 95% confidence interval for this parameter, mu diff. With the raw data, we can directly use the fact that we have those computed 18 values of the difference in energy cost with the Streak versus the Vaporfly, and therefore we can do a one sample T confidence interval on those 18 values. We would go to statistic, T one sample, select diff S minus V as our variable column, and the tab confidence interval, 95%. This gives us a 95% confidence interval that is the range 0.7037 to 1.007, which is in watts per kilogram, the units of our variable. We would get exactly the same confidence interval if we use the match pair T confidence interval. So in statistics, T paired, because we want the difference energy cost with the Streak minus Vaporfly, we would select the first variable as Streak, the second variable as Vaporfly. Again, confidence interval, 95%, and we get the same confidence interval. Fundamentally, the match pair T procedure is just the same thing as a one sample T procedure, is just a convenient shortcut to avoid having to compute all those pairwise differences if you don't already have them. Before we interpret this confidence interval, let's check the conditions for this T procedure and see if they are met. So here we have fundamentally a one sample T procedure on quantitative data. And this procedure requires that we have a random sample or a representative sample that has some random assignment of the individuals to the conditions, which is our case here. And also it requires that we have either normal data or a large enough sample size to count on the robustness of the T procedure. So we have the column for the differences already computed. So that makes our job easier. We can then plot those in a dot plot or in a box plot. And we can see that the data are more or less symmetrical. The bulk of the data sits in the middle of the range. And we have a sample size of 18, which is not particularly large, but it would be large enough for very mild skew. And so in this case here, we know our confidence interval is appropriate. Now let's interpret it in context. This confidence interval estimates the parameter mu of the variable difference S minus V. So we need to translate that in context. Our variable difference is the difference in energy cost of running when running with traditional marathon shoes versus when running with the super shoe like the Vaporfly. Mu indicates that we're estimating the mean of this variable in an entire population of individuals like the one studied. So in the population of all elite male marathon runners who would be running at top marathon speeds on a treadmill. So we are 95% confidence that on average, in the population of elite male marathon runners running on a treadmill at top marathon speeds, the difference in energy costs when running with traditional marathon shoes versus running with super shoes like the Vaporfly is a value within the range 0.7 to 1 watt per kilogram. Now, you might find it more natural to say that if the mean difference is within this range, that tells us that of the difference, one value is higher than the other. So for instance, you could say that we are 95% confident that for all elite male marathon runners running on a treadmill at top marathon speeds, on average, the energy cost of running is possibly as little as 0.7 watt per kilogram or possibly as high as 1 watt per kilogram higher with the traditional marathon shoes than with the Vaporfly super shoes. Lastly, you were asked to consider whether the confidence interval indicates that the Vaporfly super shoes are the cause of a lower energy cost, so a reduction in the energy cost of running on average in this population. This question has two components. One is, do we have evidence that the energy cost of running is lower on average for the Vaporfly than for a traditional marathon shoe like the Streak in this population? Well, we don't know exactly what the value mu diff is. We have a confidence interval for it, but the entirety of that confidence interval is positive. So we know there is a positive difference somewhere within the range 0.7 to 1 watt per kilogram. And so that means that the energy cost is higher on average when male elite marathon runners run with the Streak than with the Vaporfly. So it is lower with the Vaporfly than with the Streak on average in this population. The second aspect is whether we can conclude that this difference is because of using the Vaporfly versus using a traditional marathon shoe like the Streak. And for this, we have to go back to the design of the study, and specifically whether the two shoe conditions were the choice of the individuals or whether they were imposed with some form of randomness. And in this case here, we know that the participants didn't choose which shoe they were going to use based on their mood or how they felt at a particular time, their level of excitement, tiredness, etc. The choice was taken away from them. And instead, random order was used to determine when they were going to run with each type of shoe. So because there's no reason for it, the only logical explanation for this difference in energy costs of running on average is at some point they were wearing the Vaporfly, at the other point they were wearing the Streak.